This project is speech emotion recognition using Librosa package-based deep learning algorithm. Now I am showing the running process of this project. First, copy our file path and open Anaconda prompt. In Anaconda prompt, first we change the directory, type cd and paste our file path and type Jupyter Notebook. Now Jupyter Notebook is start the kernel and automatically rewrite the web browser to show our result. Okay, this is our home page. Here it's have dataset and our source code and dataset description and model file and readme file. Now I am showing our source code. This is our project source code, speech emotion recognition using deep learning. First I am implementing the packages. In this project, first I import NumPy, Pandas, Matplotlib, similar packages. After that, I am loading my data set and now I am showing my data set. The data sets are collected in the Google website in terms of audio files. Here it's have 6 emotion data sets. Sad, angry, disgust, fear, happy, neutral. This type of data sets are there. Now I am loading my data set. After that, I am just reading my data sets. This is sad. ANG means angry. DIS means disgust. FEA means fear. HAP means happy. And NEU means neutral. It's showing our data set. Now I am viewing my data set total. It's have 100 rows and 2 columns. This is our data set's head and tip. This is our tail. And shape is 100 and 2. Now I am showing my dataset info. It is object type. There is no null values. So that now I am showing my data visualization in graph format. Here I take labels as X label and count values takes from Y label. Depends on our data sets. And this is our speech data types file path labels and that's arrays. And our sample datasets are showing here.
I wonder what this is about.
This is angry dataset. And this is disgust.
I wonder what this is about.
Disgust discuss datasets. And next one is share dataset.
I wonder what this is about.
After that, it is happy dataset.
I wonder what this is about.
And this one is neutral dataset.
I wonder what this is about.
And final one is sad.
I would like a new alarm clock.
Yeah, this one is sad dataset. Now I am done one future extraction using Librosa. In this project, first zero crossing rates and comma STFT and MFCC and Mel spectrogram and donuts. These are done here, and it shows the result in array format. This is our X arrays. After future extraction, and this is our Y arrays. In Y arrays, it's a description. It's sad or angry, disgust, fair, happy in this format. After that, I am just done one label encoder in Y file. Now I am implementing CNN algorithm. First, I split my data like train X, test X, train Y, and train test Y. Test Y from numpy formats of arrays X and numpy formats of array Y. Here I give text size is 0.1. Now I am showing my train shape. Train X shape is 90 and 167, and text X shape is 10, 167, and train Y shape is 96, 90 and 6, and test Y shape is 10 and 6. Here 10 means rows and 6 means column. Okay, next time just expand the our data train and test sets in one line. It shows the dataset shape. And now I'm a compile the our models with I need accuracy, so that I done here. So it's just implement our CNN algorithm. After that, it's give this result. Show its layer types and their output shape. It's give multiple layers with its types. The total primes is this one, and non-trainable names is 0. It's good. And now validation data used here, text train and test Y. Train X and train Y is used for training. Test X and text Y is used for testing. So now I am epoch here for model training. Here I have done 7 epoch. So accuracy is, and validation loss and validation accuracy. It's depend on files quality, audio quality, and those models is saved in model.hp file. Now that model is tested here, and after that it gives some classification reports. It's depend on our training data set. Trained the data set. So it's showing the classifications. Finally, it's give precision result F1 score, and this one is our conclusion matrix. After that, it's give precision result F1 score. This is our class like fair, happy. These are called classes, and that's F1 score result precision. And now I am showing our model trained accuracy and loss accuracy. Like now I'm plotting on two graphs. The first graph is training and validation accuracy. Blue means train and red line shows the validation. And another one graph is training and validation loss. In here, blue means train and validation red lines. So this is our model validation accuracy, train and validation accuracy and loss. So this is our readme file. Thank you.